In this problem, we have to check whether the given string is formed by repeating some of the substrings. So let's see an example. So if you look at this string ABA, then there is no such substring which you repeat multiple times to form this ABA. Because if you have A, then you repeat it multiple times, you cannot get ABA. Next, if you take AB, again you repeat it multiple times, you cannot form ABA. You can form ABAB but not ABA. Similarly, any other character. You can try with B and any other substring. But if you look at this example, you see that it's ABC, 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 ABC. So you can form this complete string by repeating ABC multiple times. So clearly, whatever is the pattern, so let's say we have a string which is formed using some substring. So this P is not one character, but it's something like this. So let's denote this with P. Whatever pattern is being repeated. So it's like P, 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 P multiple times. So this is the string. So you have to figure out whether the given string is of this form or not. So if you have studied about KMP algorithm, for which I have already added one video. So there we used to find the longest prefix, which is also a suffix. And by prefix we mean proper prefix, because the string itself is also a prefix. So in that case, the complete string will always be same as the suffix, which is also the complete string. So that's why we take proper prefix. That is, we cannot include everything. Prefix will start from beginning. So if you exclude the last P, then this part will be same as, so this part, let's write a smaller example. P, 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 just like this one. So we cannot include the last character. So if we don't include this last character, we are removing something from the last P. So that cannot match this one. So let's say we have this form. So just ignore the last P for now. Then this is same as this. So this prefix is same as this prefix. So this will be the longest prefix suffix of n-1. That is last character. So, how to construct this LPS? Look at my earlier lesson on KMP algorithm. There I discussed this in detail. So first watch that, then come here. So now let's say this is the L, or the LPS of n-1, last one. Now what you can say? If let's say this is 0, that is, there is no prefix which matches with this. In that case, this string will not be of this form, because even if it was something like this, PP, then still this is same as this. This P is again a few characters. So if it's 0, then straight away you can say that there is no such pattern. If LPS is not 0, then what you will do? L, in this case L will be, let's say each P is of 3 characters, then this will be 9. So if you subtract n minus L, so n is this complete thing. So n is some factor of P. This is the definition of this string. It's formed by repeating P multiple times, and this denotes how many times. So n is Kp. So what will be this? Kp. And what is L? L will be some smaller Kp. It's also some repetition of the same pattern. So if you subtract these two, you will get another Kp, K prime P, let's say. Or in this case, you can say K minus 1P. So K prime P, this is n minus L. So if you take modulo L modulo this, then it should be 0. So n minus L will be, in this case, P. So L is 3P and n is 4P. So n minus L will be P. And n is this one. So L modulo n minus L should be 0. So if this is valid, then you will return true. So let's write the code for this, and again, in order to understand the code for this LPS, look at the KMP video. So we initialize it with 0 and then we start from, so for the first character LPS is always 0. L should not be 0 and so n minus L will be P and L will be some factor times key P, some K times P. And the solution is accepted. So what is the time complexity here? So the time to build the LPS array is of the order of n, where n is the size of pattern. And in this case, this is string itself. We are building the LPS of this. So time complexity will be of the order of n. And we are storing this LPS in this vector. So this is also n. So both time and space are O of n. Now let's write this in Java. And the Java solution is also accepted, and here also it's good. Finally we will write it in Python 3. And the Python solution is also accepted.